of logs. The cool part is your brain already understands this. Because what is the answer to a logarithm? What does a logarithm equal?
Exponent.
The exponent. Do you not already know? Okay, some of you hadn't quite mastered it yet. But most of you already know properties of exponents. When we multiply like bases with the exponents, when we multiply like bases, what do we do with the exponents? Add them. So look at here. When we have multiplication, we can rewrite it as addition because the logarithms are the exponents. You add the exponents. When we divide like bases, what do we do with the exponents? Subtract them. Look what happens right here. When we go from division, we can rewrite it as subtraction. And we raise a power to a power. A power to a power. What did we do with those exponents? We multiplied them. Do you see how here, when we have this logarithm and this is raised to an exponent, we can write it as multiplication? So none of these rules are new. We know them all already. Now we're just applying it to a different form. Logarithmic form. Okay? So these are our properties of logs, and we're applying it in a logarithmic form. Now the first thing we're going to do is called expanding. Well, when you think of the word expand, what do you think of?
Something bigger.
Get bigger. Yes, that's what's happening. So we're going from something compact to something that gets larger. Now generally when we expand, we're going to end up with multiple logs, either as a sum or a difference, depending on what we start with. Occasionally we might just end up with this product here. So let's look at example 1. The best way to do this is just do examples. So here I have log base 3 of 2x. Now 2 right beside an x, doesn't that mean 2 times x?
Yes.
Okay, so I have multiplication. If I am expanding this, I can rewrite this multiplication as addition, because when I multiply like bases, what do I do with the exponents? I add them. So multiplication becomes addition. So I expanded it. I started with a single log, and now I have the sum of 2 logs. Make sense? All right, next one. We have division. When I divide like bases, what do I do with the exponents?
Wait, we don't solve it?
No, we're not solving.
Oh, okay.
We will solve, but not yet. All right, so when I divide, what do? I switch it to, I heard it, subtraction. Very good. All right, so see how this single one turned into the sum of those two. The single log became the difference. All right, now, with this one we have a power. And we have this logarithm raised to a power. So a power to a power, we multiply. And all we really do is we take that power, stick it out in front, and it becomes a product. Make sense? All right. So let's go to number 4. Whoops. On number 4, we have 2 things going on. In the numerator, we actually have a product, 3 times x. And then we have this quotient divided by 7. So when we break this up, and guys, what's the base on this one? 10. Very good. So when we break this up, this multiplication in the numerator can become addition. And this division results in subtraction. So this log gets expanded to 3 logs, a sum and a difference. Now, if these were reversed and we had 3x in the denominator, we would have to group it to show both parts are in the denominator. But because it's in the numerator and we follow order of operations, we don't really have to group it. We don't need those parentheses for it to be correct. But if both parts were in the denominator, we would need it. All right, this one is a product and a power. So we're going to split it into log of 4 plus log of x. But what happens to this 5? It becomes multiplication just to the x, because that is the only part that was raised to the 5th power.
You have to return.
No, if it's the common log, don't write 10. Okay, so this one has a product and a power inside the quotient. So what we're going to do is we're going to break up that product with a sum. All right, this power here becomes multiplication. What does the division become? Subtraction. And with this 3 here, it comes out in front and becomes the multiplication. If you want to put the dot there, you can. You don't have to, because when things are side by side in math, that means multiply, right? All right. How many different things do you think this will break up into?
3.
1, 2, 3, 4. So we're going to have log of 6 plus how many logs of x? 3 log of x plus log of y plus log of z. This product turns into a long sum. So most of the time you can truly tell when we're expanding because it gets a lot bigger. This one doesn't though. We have to kind of tie this back into what we just did. We studied radicals versus rational exponents. The square root of x could be written how as a power? How could I write the square root of x as a power?
Over 2.
X to the 1/2. Very good. So this is the same as log of x, come on baby, to the 1/2 power. So what can I do with that 1/2? It can move in front and become multiplication. All right, I really like number 9 because it shows like why we would ever do this. So when we take number 9 and we expand it, do you see we have these two parts? So we end up with log base 8 of 64 plus 5 log base 8 of x. Is it possible to simplify that first expression? Yes. What is the answer to this logarithm? What is the exponent? 2. So this simplifies to 2 plus 5 log base 8 of x. And that would be our answer. Okay, so you try the you tries. Yeah, more problems. Yeah. Okay, let's see how you did. Oh, I hope not. I hope you did very well.
It's a fact.
All right, so this breaks down into log base 6 of 10 minus log base 6 of 3. Nothing simplifies. This doesn't, that doesn't, can't do anything. We can rewrite this radical as x to the 3/4. So it's 3/4 times log of x. Now this one, we can write this as 2, because of the 2, log of x minus log of 10. But log of 10 simplifies. What power do you raise 10 to get 10?
1.
1. Any questions? Yes?
You, for like number 11, do you have to put the multiplication inside?
No, you could write, if you wrote it like this, that's fine.
Okay.
other questions? All right. Okay, so now that we've done expanding, condensing is a little easier. So condensing, what does that make you think? Smaller. So we go from bigger to smaller. And generally we say when we condense, we're going to write it as a single log. What that means is you will only see LOG one time in our answer. That's the most you'll see it, once. Okay? So this is just going the other way. What would subtraction turn into if we were going to condense it? Division. So it would become log base 5 of 8 over 12. Now, does 8/12 simplify? Yes. And so since it does, we should. So after we condense, if what we have simplifies, we should do that. So it simplifies to 2/3. Now, even though these look very different, if I evaluated log base 5 of 8 minus log base 5 of 12, that's equivalent to log base 5 of 2/3. And let's take a time out on logs real quick. Log is just not a made-up imaginary thing. Logs were first introduced around 1200, and they used logs to represent really, really big stuff, huge numbers that would be hard to manipulate by hand because in 1200 they didn't have calculators or computers or any of that. So you can follow the progression of logarithms over time, but that's what they started using the idea of logarithms for. And then eventually they were actually named logarithms. What logarithms applications we use them for now? Have any of you guys heard of the Richter scale?
Yeah.
What does it measure?
Magnitude of
The
earthquakes.
magnitude of earthquakes, right? And so if we had an earthquake of magnitude 1, would we feel it? No. Do you know what that 1 means? It's the exponent. It's like 10 to the first. So that would be 10 times the normal, not quake, movement. Okay? But let's say we had an earthquake of magnitude 7. An earthquake of magnitude 7. That would be 10 to the 7th. And 10 to the 7th is 10 million times the normal movement. So see how we can use a really small number to represent a big number when we use logarithms. And that's originally why they even came up with them. Now, they weren't called logs to start with, and they didn't do the type of manipulation we could do with them then. Do any of your grandparents have a slide rule? Yeah? Guess what that is? It's a way to manipulate logs and to do operations with really large numbers. You laugh at me, but here's my slide rule. Yeah, here's my slide rule. Okay, yes. So you slide the inner and the outer and you line them up and you can perform operations quickly. So before everybody had a calculator, which seems like you have to be like 600 years old to have never had a calculator. But when I was in high school, people didn't have calculators, and I am so young. So we didn't all have them. Schools definitely didn't provide them. Nobody walked around with slide rules when I was in high school, though. Calculators were there. But my mom, when she went to college, used a slide rule. So one of my students actually gave this to me. I did not use a slide rule in college. But anyway, it's a way to perform operations with really large numbers quickly. And that's why they were invented. They really weren't invented, but defined. Okay, so back to what we do to condense them. All right, so this is hard because I don't have a space in between the 2 and the 3. This is problem number 2. And it's 3 log of x plus 5 log of y. So if we're going to condense that, The addition turns back into multiplication. But what do the 3 and 5 do? They go back and become those powers, the exponents, yeah. So that gets rewritten as log of 3 to the x, y to the 5th. X to the 3rd, y to the 5th. All right, so this one, the 2 goes back and becomes the exponent. The addition becomes multiplication. So we get log of x squared 5. That doesn't make any sense, does it? How should we write that? 5x squared. Very good. Log of 5x squared. Okay, example 4. So here we have 10 log of x plus 2 log of 10. So this becomes the exponent. This becomes the exponent. So if we were to write it as a single log, it would be x to the 10th times 10 squared. Well, what is 10 squared? 100. So it would be log of 100 x to the 10th. We would want to write it in proper form, and in proper form the coefficient would come first. Okay, number 5. We've got a power right here, which creates log of 1/2 squared. And when we square 1/2, we get 1/4, don't we? When you square 1/2, you get a 4th. So now we're doing 20 times a 4th times x. So we have log of 20 times a 4th times x. What's a 4th of 20? 5. So that simplifies to log of 5x. All right, this one, the subtraction becomes division, and 16 divided by 4 is 4. Becomes log of 4. All right, this one has a whole bunch of stuff. So this becomes a power, a power, a power, and this one's straight out multiplication. So plus plus becomes times times. So it becomes log base 4 of 2 to the 5th, x to the 7th, y to the 3rd. What is 2 to the 5th? It is. So it becomes 32, x to the 7th, y to the 3rd. Okay, so you take a minute and you try the next couple.
Yeah, no.
All right, so there they are. If you have any questions about these, let me know. And tonight's homework is on the back of last night's. Remember, we skipped day 10. That was one of the days we chose to eliminate because that information wasn't as critical as the days we're keeping. Okay?
So much sense now. I was trying to do the back last night and it was so ridiculous.